So it reads, oh, by the way, all these word problems are in Google Classroom under syllabus. It says word problems doc, so it's there for you. So you don't need to copy down all these word problems. You already have them there. Hey, in a certain three-digit number, if the sum of the digits is doubled, the result is 16 more than 3 times the tens digit. 1 more than twice the hundreds digit is the units digit. The hundreds digit is 11 decreased by twice the tens digit. Find the 3-digit number. Okay, so when we have a 3-digit number, I'm just going to make one up. This is not the 3-digit number for this problem. Let's say I have like 764. Okay, I have 764. All right, this is obviously a 3-digit number. All the way to the right, that is the ones digit. The middle one, so it's ones and then tens and then hundreds. Right. So in a certain 3-digit number, the sum of the digits. So really, they're just talking about each of the individual digits, right? The ones digit, the tens digit, the hundreds digit. Are they talking about the value of these digits? No, they're just talking about the digits. So we're going to say, I'm going to let H equal hundreds. I'll let T equal tens. And here they're not calling it the ones. What are they calling it? The units. That's the same as the ones. So I'll let U be the units. Since we have 3 different variables, how many different equations do I need? 3. Whenever you're solving a system of equations, you need a different equation for however many different variables you have. So if you have 2 different variables, you need 2 different equations. If you have 3 different variables, we need 3 different equations. So here it says a certain 3-digit number, if the sum of the digits is doubled. All right, so let's translate exactly. The sum of the digits, what am I doing? Adding them. H plus T plus U. But then what are we doing with that sum? Multiplying it by 2, because it says the sum of the digits is doubled. So we're going to multiply that by 2. The result is, that means, equals 16 more than 3 times the tens digit. Can someone translate that for me? 16 more than 3 times the tens digit. Dylan.
16 plus 3t.
Good. I'm going to just write 3t plus 16, but it's the same thing because addition's commutative. That's my first equation. How many equations do we need? 3. Okay, next one. Keep reading our word problem. 1 more than twice the hundreds digit is the units digit. All right, 1 more than twice the hundreds digit. Can somebody start that part off for me? 1 more than twice the hundreds digit. Arish.
2h plus 1.
You got it, 2h plus 1. 1 more than twice the hundreds digit is means equals the units digit, which is U. That's my second equation. What are we doing now? Our third equation. Keep reading. The hundreds digit is 11 decreased by twice the tens digit. The hundreds digit is. So what is that? The hundreds digit, which is H, is, which means equals, 11 decreased by twice the tens digit. So it's 11, and then what are we doing? Minusing, good, twice the tens digit, which is 2t. Do we have our 3 equations? Yes. All right, let's solve this one by hand. Let's solve this one by hand to refresh our memories how to solve a 3 by 3 by hand. So I'm going to go ahead and I'm going to solve through elimination. I'm going to go ahead and I'm going to solve through elimination. When we solve through elimination, I want all the variables for every equation on one side. I want the numbers without variables on the other side. So let's go through this and let's distribute in that too. So we're 2h plus 2t plus 2u equals 3t plus 16. I'm now going to subtract the 3t. When I subtract the 3t, we get 2h minus t plus 2u equals 16. That's my first equation in elimination format. All right, the second equation, we need to manipulate things here also. So what am I going to do? I'm going to subtract the 1 over and also subtract the u. So this becomes 2h minus u equals negative 1. All right, and the last equation, I'm going to add the 2t over. So we are h plus 2t equals 11. Okay, so now what we're going to do is we are going to choose 2 of the equations and eliminate 1 of the variables. We're going to choose 2 of the equations and eliminate 1 of the variables. Do you think it matters which 2 equations we choose? No. All right, so I'm going to go ahead and I'm going to line up the first one, 2h minus t plus 2u equals 16. And I'll line up the second one right underneath of it. Do I have any 10 digit for the second one? So I'm just going to put 0t for that. So we're 2h plus 0t plus u equals negative 1. Was it a minus u? It was a minus u. Thank you. All right, now what I'm going to do is I'm going to, let's eliminate the h's. Let's go ahead and eliminate the h's since they're both 2h. So all I have to do is distribute in a negative to the bottom one. And then add. When I add them, the 2 h's cancel. And then I'll have a negative t plus a positive t is a negative t. 2u plus 1u is 3u. And now that's going to equal 17. So if you all remember, now what we have to do is choose a different 2 equations and eliminate the same variable. So I chose the first and second one. Now I'm going to choose the first and the third one. Let's choose the first and the third one now. So I'm going to have, could we have chosen the second and the third one if we wanted to? Yeah, it doesn't matter. So now we have 2h minus t plus 2u equals 16. And I'm going to have h plus 2t plus 0u equals 11. I'm going to multiply the whole bottom equation by negative 2. So when I do that, the top equation stays the same, 2h minus t plus 2u equals 16. And in the bottom equation, we're going to have negative 2h minus 4t plus 0u equals negative 22. And let's add. The 2 h's cancel. We get negative 5t plus 2u equals negative 6. Okay, so now what do we do? See my two cloud equations that I got? So now they're both in a two variable equation format, right? So now I can use these two and solve for one of those variables. So let's line them up. I have a negative 5t plus 2u equals negative 6. And then I'm going to have a negative t plus 3u equals 17. I'm going to multiply the whole bottom equation by negative 5. So the top stays the same, negative 5t plus 2u equals negative 6. In the bottom equation, we're going to get 5t minus 15u equals negative negative 85. Does that sound right to you? Okay. The t's cancel. So now we are going to get negative 13u equals negative 91. So u will equal 7. Thank you. What am I going to do now? David?
Could you phrase like the other two equations I still got the same answer?
Yeah, of course. All right, so now what are we going to do with that u? Plug it in. So I'm going to go back to one of the equations. I'm going to go back to, I don't know, negative t plus 3u equals 17. So now we are negative t plus 21 equals 17. What do we get for t? Anybody solve it? 4. Good. So I got u, I got t. Now what do I have to get? H. Does it matter which equation I plug into? No, I'm going to go back to one of the originals. H equals 11 minus 2t. So H will equal 11 minus 2 times 4. So H will equal 11 minus 8, which is 3. We solved for H, we solved for T, we solved for U. Okay, so now, did everybody get this? So now I'm going to add a little bit of an extra thought here into the next word problem, because the first one was nice because it was all just talking about its digits. It wasn't talking about the value the digits held. It wasn't talking about the values. But this time it is. It says a 2-digit number is 9 less than 4 times the sum. It should say of its digits, not if its digits. Right? So a 2-digit number is 9 less than 4 times the sum of its digits. If the digits are reversed, the new number is 54 more than the original number. Find the original number. All right, to start off, it says a 2-digit number. Okay, so if we're only 2 digits, what digits are we dealing with? The units and the tens. So I'm going to go ahead, I'm going to let t equal tens and u equal units. Okay, so it says a 2-digit number is. They're not saying just their digits. They're saying the whole value of this 2-digit number. The value that this 2-digit number holds. So I can't just write t plus u. If I just write t plus u, let's say t is 7 and u is 1, isn't that just 8? Right? That's not representing that 2-digit number. So how am I going to manipulate t and u to show that it represents a 2-digit number that has its correct value? Ryan? You got it. Because isn't the tens digits 10 times whatever that digit is? Plus the units digit, which is just 1 times whatever that number is. Does that make sense? All right, so it says a 2-digit number is, what does that mean? Equals 9 less than 4 times the sum of its digits. So now they're just talking about the sum of its digits. So do I need to do 10t and 1u again? No, they just want to add the digits. So we're talking about 4 times the sum of their digits, but 9 less than that. So at the end, minus 9. That's our first equation. How many equations do we need? 2. All right, now it's saying if the digits are reversed, what does that mean? Let's say my number is 47. If I reverse the digits, what does the 47 become? 74. So what's happening when I reverse the digits? The 1's digit gets multiplied by 10, and the 1's units digit gets multiplied by 10, and the 10's digit is just 1's, right? So we're going to have, instead of 10t, we're going to now have 10u plus t. So I just reversed the digits. If the digits are reversed, the new number, 10u plus t, is, which means equals 54 more than the original number. Well, what was the original number? 10t plus u. But it's 54 more than that. So what are we going to write? Plus 54. Do you all need to see me solve this? If you want me to, I will. Anybody want to see me solve a 2 by 2? Okay, that's fine. So I love elimination. My go-to is always elimination, unless substitution is so very obvious. So for me, let's go through, put it in elimination format. So I have 10t plus u, let's distribute in this 4, equals 4t plus 4u minus 9. Get all the variables on one side, so we end up with 6t minus 3u equals negative 9. Can I reduce this down? 6t minus 3u equals negative 9? Absolutely, and I'm going to. I'm going to divide everything by 3 to make my equation smaller. So then I end up with 2t minus u equals negative 3. All right, the next one. Get everything over to one side. So again, I have, I want my t first. I want my t first. What do we get? Negative 9t plus 9u equals 54. Again, can I simplify this down? Yeah, and I'm going to divide everything by 9 to make my number smaller. So now we're at negative t plus u equals 6. Right, at this point, I'm now going to stack them up. So I'm 2t minus u equals negative 3, and then negative t plus u equals 6. I don't need to do anything. I could just add these equations because the u's are going to cancel. So I'm going to end up with t equals 3. And now what are we going to do? Plug in for the u. So now I'm going to have negative t plus u equals 6. So negative 3 plus u equals 6. U is equal to 9. So it says, find the original number. What is the original number?
39.
You got it, 39. All right. We ready? It says powdered milk worth $3.60 per kilogram and cocoa worth $5.20 per kilogram are to be mixed, so their combination is worth $82.40. how many kilograms of milk should be used if the weight of the milk is 10 times that of the cocoa? Yes.
Can you ever guess and check?
No. If you guess and check, and let's say you get the right answer, you get 1 point for having the right answer. The other 5 or 4 points, of regard, depending on how much I make it worth, is all based on your work. There is no guess and check. All right. So back again, powdered milk. Okay, what are we looking for? How many kilograms of milk should be used if the weight of the milk is 10 times that of the cocoa? So we're talking about weight, right? So I'm going to have X equal weight of the milk. And I'll let Y equal the weight of the cocoa. I have 2 different variables. Since I have 2 different variables, how many different equations do I need? 2, right? All right, so powdered milk worth $3.60 per kilogram and cocoa worth $5.20 per kilogram are to be mixed, so their combination is worth $82.40. This is my first equation. All right, do we know how many kilograms of milk or how many kilograms of cocoa we're using? No, but we know for every kilogram of milk, it's worth $3.60. So we're going to take $3.60 and multiply it by the amount of weight we're going to use, right? So my first equation is going to be 3.6. Do I need to put that 0 in? No. 3.6x plus 5.2y equals how much? 82.4. That's my first equation. Second equation. All right, how many kilograms of milk should be used if, all right, the weight of the milk is 10 times that of the cocoa? All right, we're not talking about their financial value anymore, right? Now we're just strictly talking about the weight. We know the weight of the milk is X, the weight of the cocoa is Y. So they're saying the milk is, so what did we say milk is represented by? X is 10 times that of the cocoa. So how am I going to represent that? 10Y. In this scenario, I actually think that substitution is our better option, even though it's all the same. Just because we're already in that format, it's an easy just substitute in. So what I'm going to do before I substitute in, I'm going to multiply the whole top equation by 10. Why do you think I'm multiplying the whole top equation by 10? Just to get rid of the decimals. So we are 36x plus 52y equals 824. So now, anytime I see an x, what am I going to do? Substitute in 10y. Yes, David? You don't have to. No. So then you could work with the decimals if you like. So then we're going to have 36 times 10y plus 52y equals 824. All right, so we're 360y plus 52y equals 824. I will tell you y will equal 2. If you plug in, you're going to get x is equal to 20. And I'm not sure what it was asking. What was it asking? How many kilograms of milk? How many kilograms of milk? 20 kg. All right, let's do a calculator one. Let's do one for the calculator. Are we ready? These aren't so bad, right?
No, just tedious.
Everything about this unit is tedious. I agree.
Why do we need to do all this tedious?
It should be a 2-day test.
Math is supposed
Can
to
you
be
just split the word problems like some on calculator, some on the calculator, or are they going to be in one section?
I'll tell you on Thursday. I'll tell you on when do we review Wednesday? I'll let you know Wednesday once I finish making the test. Yes.
Could we do a calculated day and a not calculated day?
No, sir? All right, let's go. I know, this is miserable.
Why would we work for 2 days?
Yeah, prolonging the stress is no good. All right, 60 tickets, hush children. 60 tickets to an event were purchased by a group. Some cost $4 each, some cost $6 each, and some cost $10 each, and some cost $18 each. Right away, what do we know this is going to be? Yeah, 4 variables. All right, so since we know it's going to be 4 variables, let's keep reading. The amount paid for the $4 and $10 tickets exceeds the amount paid for the $18 tickets by $20. The amount paid for all 60 tickets was $488. The number who purchased $4 or $18 tickets was the same as the number who purchased $6 or $10 tickets. How many $10 tickets were purchased? Okay, so we're going to let A equal amount of $4 tickets. We'll let B equal the amount. What was the next number? $6. C will equal the amount of $10 tickets. And D will equal the amount of $18 tickets. Okay. 60 tickets to an event were purchased by a group. Is that an equation right there? Absolutely. What is the equation? You got it. A plus B plus C plus D equals 60. All right, some cost 4, some cost 6, some cost 10, some cost 18. Got it. The amount, all right, so now we're talking about a financial amount. So they're saying the amount paid for the $4 tickets. So how am I going to represent the amount paid for the $4 tickets? 4A. So the amount paid for the $4 tickets and $10 tickets. What does that mean? And $10 tickets, so plus 10C, not just C, 10C. So the amount paid for the $4 tickets and the $10 tickets exceeded the amount, I'm just going to put an equal sign here, and then we'll talk about that exceeded, okay? Exceeded the amount paid for the $18 tickets. So do we agree on the other side is 18, D, thank you. All right, by 20. All right, so which exceeded which? Did the left exceed the right, or did the right exceed the left? The left exceeded the right, meaning the left is higher than the right. So to keep it balanced, I'm not going to add 20 to the left, right? Because that's just making it even bigger. To keep this balanced, since this exceeded this, where do I put the 20 to keep it balanced? With the 18D. Does that make sense? Everybody always wants to put it on the other side.
Can you subtract 20?
You can. If you wanted to subtract 20 from the 4A and 10C, you absolutely could. That's my second equation. Can we keep going? How many equations do I need? Good. The amount paid for all 60 tickets was $488. There's another equation. How am I going to represent this? You got it. One more equation. All right, the number who purchased $4 tickets and $18 tickets was the same as the number who purchased $6 or $10 tickets. Now, are we talking about the amount of money they made or just the amount of tickets sold? They're just talking about the amount of tickets sold. So am I going to do like 4 times A or 6 times B? No, we're just talking about the amount of tickets sold. So this is just A, B, C, D, whatever we're going to use. So the number who purchased $4 tickets or $18 tickets. So A is $4 tickets, right? Or $18 tickets, what is that? Plus D was the same as, what does that mean? Equals the number who purchased $6 or $10 tickets. So what am I going to write there? B plus C. All right, we are going to use a calculator. In order to use a calculator, what do I have to do to all these equations? Good. Get all the variables on one side. We sort of set it up to plug it into a matrix. No, don't do that. Okay, so we're going to have A plus B plus C plus D equals 60. We're good there. Then we're going to have 4A. All right, what do you think I'm going to plug in when there's no variable? 0. You got it. 0B plus 0B plus 10C minus 18D equals 20. And then we're 4A plus 6B plus 10C plus 18D equals 488. And then we're going to have A minus B minus C plus D equals 0. Is it okay that it equals 0? Yes. All right, now I want the variable matrix. My variable matrix, which is A, B, C, D, is going to equal the inverse of the coefficient matrix. So we're 1, 1, 1, 1, 4, 0, 10, negative 18, 4, 6, 10, 18, 1, negative 1, negative 1, 1. The inverse of this times the solution matrix, which is 60, 20, 488, 0. Do you need to see me plug this into the calculator? Yeah? No? Yes? No? Anybody want to see me do it? Raise your hand. No? Nobody needs to see me do this? We're good? Okay, nice. All right, yes.
On the test, do we have to rewrite the equations, or can we just go from the 4 original ones straight to the equation?
You can go from this to that. You don't need to rewrite them. So your answer should have been how many $10 tickets were purchased? 12 $10 tickets were purchased. Did you type in all your numbers correctly?
Yeah, I know. Oh, I put 18 cents on the screen.
There you go. That's why. Yeah, so it's very finicky because if you're not putting everything in correctly, it's going to throw your whole answer off.
Yeah, I got 12
now. Did somebody else have a question that I didn't hear? I heard somebody ask me something, but I didn't hear the question. No? We're okay? No, we have one more. That's fine. Thank you.
Is it calculated question?
We could just set it up. We don't even have to solve it. It's just it's just a regular system of 2. All right, so it says a collection of quarters and dimes contains 44 coins and has a total value of $6.50. We're talking about the financial value. Because we're talking about the financial value, we have to remember that a dime is more than a nickel, a quarter. Oh, this is just quarters and dimes. Okay, a quarter is more than a dime. Okay, so we have to remember it makes a difference now. How many of each type is in the collection? So I'm going to let Q equal number of quarters, and we'll let D equal number of dimes. All right, first sentence, a collection of quarters and dimes contains 44 coins. That is my first equation. What are they talking about, the financial value, or are they just talking about the physical number of coins we have? Just the physical number of coins we have. So this is just going to be a Q plus D equals 44. But now it says it now has a value of $6.50. That makes a big difference now. Now we're talking about the value, right? A quarter is worth how much? 25 cents. A dime is worth how much? I heard it? 10 cents. Okay, so what I'm going to do is I'm going to put this all in terms of pennies. So for my second equation, I know 25 pennies times the number, 25 cents times the number of quarters we have will give me my total financial value of quarters. Plus 10 cents times the number of dimes we have will give us our total financial value of dimes. All together, what should this equal? Good, 650. How come I didn't put 6.5? Arish? Good, because I'm basically talking about pennies here, right? I'm putting everything in terms of pennies. 25 pennies, 10 pennies, so $6.50 is 650 pennies. All right, we have our two equations. Do you need to see me solve this? No. You should get 14 quarters and 30 dimes. All right, you do not need to do the independent, but I will give you the answers for these in case you do want to do them. Here, original is 25. Dried fruit is 4.2. Raisins equals 6.3. Number 3, adult will be 900. Student will be 700. All right, number of $1 tickets is going to be 11. $5 tickets will be $5 tickets will be 7, and $10 tickets will be 5. The original number is 98. And the last one, first number is 4, second number is -5. All right, you have homework. It's in the textbook. I will post that for you. Yep, it's due Wednesday. Everybody say bye to Ariana. That was not nice. Bye, Ariana.